Let's see graph of a parabola. See any equation given in the format y is equal to ax square plus bx plus c is actually called a parabola. It has a particular shape. We'll be discussing about this shape. And over here, condition is only one thing, that a must not be equal to 0. Because if a is actually equal to 0, then the equation would be left as y is equal to bx plus c. And as most of you know it, this is a straight line. So the only condition over here is a must not be 0. See, I wish to see the shape that is the graph of this parabola. To plot the graph of this parabola, I'll again go to the concept of maxima and minima, where I'll try to judge things out from here. See, y is equal to ax square plus bx plus c. For maxima and minima, I need to know two sort of points. One is critical point, two sort of critical points. One is called endpoints, another is called turning points. If you see endpoints would occur at x tending to infinity and x tending to minus infinity. And turning point would occur at dy by dx equal to 0. See, over here there is no restriction on x. So as just now discussed in the previous problem also, if there is no restriction on x, then x can be anything. So the graph would start from minus infinity and end at plus infinity. And to check the turning point occurs at dy by dx equal to 0. If dy by dx has to be 0, that means d by dx of y can be written as ax square plus bx plus c must be 0. If you differentiate that, then you will have 2ax plus b must be 0, or x is equal to minus b by 2a. So the turning point occurs when x is minus b by 2a. Now, let's check the value of y at these points. One is x tending to infinity. If you take x tending to infinity, then y is actually ax square plus bx plus c. To deal with infinity, always take x square common. We'll have a plus b by x plus c by x square, which makes it as infinity square times a plus b by infinity plus c by infinity square. Any number divided by infinity clearly becomes 0. So this is a into infinity square, which would have two possible outcomes. Either this would tend to infinity or this would tend to minus infinity. See, infinity square is positive. So either it would tend to infinity or it would tend to minus infinity. That depends on a. If a is positive, then the number would tend to infinity, and if the same a becomes negative, then the number would tend to minus infinity. So a plays a very important role over here. Second, if you check x at minus infinity, y would be equal to ax square plus bx plus c, which can be done by taking x square common, which is a plus b by x plus c by x square, which again takes minus infinity ka square common times a plus b by minus infinity plus c by minus infinity whole square. Any number divided by infinity becomes 0. So it is a times minus infinity ka square. And when you square a negative number, it becomes actually positive. So this is a times infinity square. Again, it is same as previous case. It may tend to infinity or minus infinity. It would tend to infinity if a is positive, and it would tend to minus infinity if a is negative. So everything depends up till now on a. And third is x is equal to minus b by 2a. If x is equal to minus b by 2 is checked, at this point y is equal to ax square plus bx plus c, which is a into minus b by 2a ka whole square plus b into minus b by 2a plus c. So this is b square by 4a minus b square by 2a plus c, or c minus b square by 4a, or 4ac minus b square by 4a. This is the value of y at this point. Now you can actually see graph. Two possible cases over here can be framed. One, a greater than 0. If a is greater than 0, then both at x tending to infinity as well as x tending to minus infinity, y tended to infinity. What that means is, if you take the graph over here, this is my y-axis, this is my x-axis, And when this is my minus x, this is my minus y, and when x tends to minus infinity over here, when x tends to minus infinity, y goes to infinity, so the graph starts from this point. If the graph starts from this point, clearly beyond this, the graph has to slow down. If it slows down, then the minima over here, then it would decrease from this point, and it keeps on decreasing, keeps on decreasing, keeps on decreasing, till a point where x is minus b by 2a, and you have a particular y. And then you start increasing, 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 and then the graph ends at infinity. This is how the graph is formed. This case occurs when y is equal to ax square plus bx plus c, where a is actually greater than 0. And this case is called as an upward parabola. In the same situation, if a would have been negative, then at both x tending to infinity and x tending to minus infinity, y would have been tending to minus infinity. That means the graph would have been slightly different. Let's say this is y-axis, this is x-axis, this is minus x, this is minus y. Where when x tends to minus infinity, y also tends to minus infinity, and when x tends to infinity, y ends at minus infinity. So the graph starts over here, so this is the starting point, and ends over here, so this is the ending point. Clearly, from minus infinity, somebody would rise only. So it keeps on rising, keeps on rising, keeps on rising, and then it starts to fall, ultimately falls over here. We have only one turning point over here, which is at minus b by 2a and has a particular value of y naught. This started from the same equation y is equal to ax square plus bx plus c. But since the head is coming, the nature is downward, so we call it as a downward parabola. So the nature is a parabola. If a is positive, then it is an upward parabola, and if a is negative, then it is a downward parabola.